Hello there, this is Justin from Black Module Studio, bringing you my third Unity tutorial. This one is going to be on, first off, creating a mesh at runtime, and then I'm going to show you how to deform that mesh at runtime. So here we go, I guess. Alright, so first off, go and open up Unity. Right here I have a the project that I have been using for these tutorials. I'm going to go in here and duplicate this scene. Make sure that's the one that's open. Alright. And we're not going to be using the terrain, so I'll delete that. And then let's go and start off with a new script. Create a folder for it first. Alright, and like the other videos, I'm just going to be working in C#. And we're going to call this a Deformable Mesh. Alright, let's go ahead and open that up. Okay, so a couple things first off. We're going to be using something called a list. So in order to use that, we need to include system collections generic. It's going to let us use the list. And then first off, to make a mesh, well, we're going to need a mesh, so we'll do that. And then meshes have a material, so right there. And then what we're going to need, we're going to have four different kinds of lists. The first list is going to be a list of vector 3s, and those are going to be the points. Then the next is going to be a list of vector 3s again, but that's going to be the vertices. I'll just call it verts. And we'll need another list. This is going to be a list of integers, and it's going to be the triangles. And finally, we're going to have a list of vector 2s, and that's going to be the UVs. So essentially, first off, I'm just going to show you how to make a cube. Now, a cube has 8 different vertices at first glance. That is what I'm actually calling the points. Now, when you render a cube, you're actually each face has the 4 vertices. But so if the front face has the 4 vertices, the top face uses 2 of those vertices also. So the list of vertices is going to have all of the it's going to double up on multiple points. So yeah, I believe it's, how many are there? 36, I believe, different vertices we're going to be using. We'll find out when we get to it. Okay. So moving along. One last variable. This is just to make things a little bit easier and customizable. We're just going to have float that's going to be for the size. I'm going to say 0.5f. And that's kind of like the radius, if you will. Alright, so now in our start function, what we're going to want to do is we're going to create that list of points. So we'll say points equals new list vector 3. That's going to create the list for us. And then we're just going to go and start adding points. So we'll say points.add new vector 3. We're going to say negative size, negative size. And then we're going to copy paste this. So that's going to be our all 8 points. Oops. Yes, and then this one will be positive, negative, negative. And then the last one will be all negative. Alright, so then this one should be all positive. If you're unsure of what I'm doing, I'm essentially creating all the points. So okay, so the first parameter in vector 3 represents the x coordinate, then the y coordinate, then the z coordinate for a point in 3D space. So basically we're starting at negative size, which is negative 0.5 on the x, so just a little bit to the left, and then size, so 0.5 on the Y, so that's top, and then negative size, 0.5. So that's going to be the front. Well, I guess it depends on how the camera is positioned, but basically how I have this set up is it's going to be the front left top point of the cube. So you can kind of see what I'm doing here. Alright, and then this one is going to be negative, positive, positive, and then negative, negative, positive, and then we're going to say positive, oops, I forgot that one. It's going to be positive, negative, positive. Okay, so that's all of our points. Then we need to initialize our verts list. Oops. And our tries list. And then finally our UVs list. Vector 2. Alright. And then that's basically all of our setup, except we're going to call a function that we'll create right after this. And it's create mesh is what I'm going to call it. So let's go down here under the update function. And so this function, create mesh, is not going to return anything. So we'll just say public void create mesh. Actually, that can be private. Alright, so now to create a mesh, the first thing that we're going to have to do is oh wait, you know what? I think I missed something. Nope, we're good. Okay, so we're going to say game object dot add component mesh filter. So it's going to add a mesh filter to the game object, because we're going to attach the script to a game object. Okay, so then we're going to say game object dot add component mesh renderer. Basically what we're going to do is we're going to create an empty game object and attach this. There are other ways to do it so that you won't need to do that. It's just the option or the route that I'm taking for this. Okay, so game object dot add component and a mesh collider. Now we need a collider for the mouse picking to work. That way when you click on it, you can deform it. Now there are other reasons to have the mesh collider also. Perhaps you want your object to have physics, or be able to be collided with, or whatever. It really depends on how you're using it. But if you don't need a mesh collider at all, if you don't want this to be deformable, if you're just trying to figure out how to create a mesh, then you can leave the mesh collider out and all mesh collider related code. So, alright, now remember we have to have a material, so what we're going to do is we're going to do the code for that. First off, I'm going to check or set mat, which is our up here, our material variable. I'm going to set mat equal to resources dot load materials slash default, and that's going to be as material. That's essentially just casting as material, ensuring it's material. So first off here, let me pop back into Unity real quick. Now you're going to need, whenever you call resources.load, you need a resources folder, and it's going to go into that folder, and then it's going to load the file you tell it to. Oh, here we go. So we're telling it to go into the materials folder, and this can be whatever you make it. I just call it materials, and then we're going to load the default material. So in the materials folder, default. Now that's just the standard material. I just right clicked, I said create material, and then I named it default. So I didn't change anything else about that. You can obviously change it and do with it what you will. Alright, so now that we got this material, we need to do just a quick error check right here. Check, see if it's null, as in didn't load, and we'll go ahead and do debug.log error we'll say material not found, and then we will return. So that way it's going to throw an error if the material is not there, which we want. Then we're going to set the mesh filter. Oop, I spelled that wrong. Filter. Create a mesh filter. And get component mesh filter, which is going to be this one that we added earlier. And then we're going to check if the mesh filter is equal to null. Just more error checking, and we're going to go and log another error. We'll say mesh filter, filter not found, and then we will also return. Alright, now just a little bit more error checking. We're going to set the mesh equal to the mesh filter dot shared mesh, and then we're going to check if mesh equals null, and if it does equal null, then we'll set the mesh filter dot mesh equal to new mesh. So we'll create a new mesh, and then mesh will equal to mesh filter dot shared mesh. Alright, and finally the mesh collider. We'll go ahead and get that one. Oops. There we go. And that's going to be get component mesh collider. We'll say if mesh collider is equal to null. We'll go and log another error. Now we need to clear the mesh in case there's anything residual in there, and then we're going to call another function that we're going to call update mesh. And that's essentially we're going to be actually setting all the points and whatnot, and actually building the mesh up. So this will be private, and it's not going to return anything either. So say update mesh. Don't need to pass any parameters to it. First off, we're going to create the front plane, and we're going to do verts.add. So basically we're going to be adding the different points that we created earlier up here, and we're going to add those to the verts array, or sorry, verts list. So so for the front plane, we need to add point 0. Here, I'm actually going to copy this several times just because it's a lot of the same code. Oop. Alright, so it's going to be 4 points per plane, so that's going to be the first plane. I guess I could just copy the comment too. Okay. 4, 5, 1, 2, 3, 4, 5, 6. Alright, perfect. Alright, so there's 6 planes. We're going to do the front, then the back, and then we'll do the left, and then we'll do the right, top and bottom. Alright, so the front plane is going to be 0, 1, 2, 3. So that's the first, it's just because that's how I built the points list up here. So essentially, 0, 1, 2, and 3, those 4 points out of the 8 total points make up the front plane. Alright, and then the back plane is going to be 4, 5, 6, and 7. So that makes sense. Now the left plane is going to be 5, 0, 3, and 6. And then the right plane is going to be 1, 4, 7, 2. So we got this. top plane, we're going to have points 5, 4, 1, and 0. And then the bottom plane is going to be 3, 2, 7, if I can get there, and 6. Alright, so that's going to be our list of vertices. So yeah, so it was 24 vertices. I don't know what I think it said 48 earlier, or 36 earlier. Alright, so now we need to build our triangles out of those specific vertices. So again, we're going to have a front plane, and our triangles, we're going to say tries.add. We're going to add 0. Remember, these are integers, and what the integer you're passing is the index into the verts array. So for the first triangle, it's going to be 0, 1, and 2, which would be this one, and this one. So we're going to say, sorry, for the first triangle of the front plane. Each plane has 2 triangles, obviously. So we're going to say, we're going to do it like this. So that will be, you know, the first triangle on this row, and then the second triangle. So we're going to say 0, 1, and 2, and then it's going to be 2, 2, 3, and 0. Alright, so now we'll go ahead and do all the other planes. Just going to do similar real quick. Alright, so let me just copy all this, make it a little bit quicker, because I'm pretty sure you guys are understanding this. And if not, just go and feel free to ask the questions in the comments. I'm usually pretty good about getting right back to people, just because I got it send me an email whenever you guys comment. So anyways, yeah, so front, back, left, right, top, and bottom. So the first triangle of the back plane is going to be 4, 5, and 6. 4, 5, and 6. And then for this one, it is going to be 6, 7, and 4. So you guys might see a pattern here for those. Alright, now the left plane is going to be 8, 9, 10, and 10, 11, 8. 8, 9, 10, 10, 11, 8. And then when I'm editing this video, I may speed past this, maybe not. I guess if I speed past it, you probably won't hear me saying this. So, alright, so we got 12, 13, and 14. And then we have 14, 15, and 12. So 16, 17, and 18. Alright, and then for the next one we have 18, 19, and 16. You can probably see a pattern here. And then 20, 21, and 22, 22, 23, 20. Alright, so that's our triangles, all 6 of the planes. And next, you guessed it, we're going to do the UVs. So which this basically helps map textures to it. Now, with our default material, this isn't going to matter because there's not a texture, it's just a solid color, but this is going to allow you to actually texture your objects also. So yeah, so essentially we're going to send it a bunch of vector 2s, and they're going to be 0, 1, or sorry, 0, 0, 0, 1, 1, 1, or 1, 0, and 1, 1. That's it. So 4 different ones. And that's just basically the X and the Y, 0 to 1 for each corner. So, alright, we're just going to go and label these again. So front plane, and then we're going to do UVs.add. We're going to pass a new vector 2, and the first one is going to be 0, 1. And we are going to do 4 of these for the 4 corners per plane. Why did I do that? There we go, 2, 3, 4, 5, 6, all the planes. So let's go and copy this so they're labeled correctly. Oh. Alright. Now, so it's going to be 0, 0, 1, 0. Or sorry, 1, 1, 1, 0. And I said that totally wrong. 0, 1, 1, 1, 1, 0, 0, 0. And actually, I don't know why I did this, but it is exactly the same for all of them, I believe. Yep. So that's easy, that's done. So now what we need to do is some of the important stuff. Alright, we're going to first off do mesh.vertices, and this is actually an array. We could have built ours with arrays, but it's just easier and faster to use list. So we're going to do mesh.vertices equals verts.toArray. That's a function. Basically, that's a function of the verts that, of the list object that will turn the list into an array. So we're going to do this for the vertices, the triangles, and the UVs. So we'll say triangles, if I can spell, and then UVs. So that's our tries, and then our UVs. Oops. UVs. Alright. Now we've moved all that data that we've just built into the mesh. Now we're just going to go and clear our verts, our tries, and our UVs. What am I doing? Clear. There we go. So that's going to clear them. That way when we use the add function, because we're going to go into this object multiple times, or sorry, function multiple times. So now whenever we use add, it's not adding it on top of this data. It's going to be new data. Alright, so now we take the mesh collider object. We'll create a new one, say my MC for my mesh collider, and I'll just call it mesh collider. I actually don't like doing my this, my that. I just kind of sometimes do it out of habit. Mesh collider. Alright, and then we're going to say mesh.recalculate. What am I doing? Recalculate. Calculate normals. And then mesh.recalculate. I don't know why I'm having such a hard time spelling that. So recalculate bounds. And then this is a function that we'll build momentarily, but right here we're going to want to recalculate the tangents. This is going to help with our lighting and shading. We're going to pass the mesh in. And then we're going to say mesh collider dot shared mesh equals null. Okay, and real quick, with Unity, we have to set the shared mesh on the mesh collider first to null and then to mesh, otherwise it won't update. I'm not sure why that is. I don't know if that's necessarily a bug in Unity, or if there's a specific reason for that, maybe a performance issue. I have no idea what the reason is, but I do know that if you just try and set the shared mesh equal to the mesh, once you've done all that, the mesh collider actually won't update. And I can comment that out to show you guys just that simple line, but setting it to null first and then setting it to the mesh will actually trigger it to actually update the collider. Then we're going to set our render.material equal to matte, and then we're going to do mesh.optimize. Alright, so that's really the beef of the actual code. Oh, you know what? Actually, no, we need to do the recalculate tangents function, and then that'll be the beef of the code. So we'll say private static void recalculate tangents, and we need a mesh in there. And then first up, we're going to, this is just, hold on, what am I doing? Here we go. Sorry, we're going to do an array of integers, and that's going to be our triangles. And basically this is just a little optimization, so we're not constantly reading from, because we're going to go through a for loop, so we're not constantly reading from the mesh object. So we're actually just going to cache this stuff. So mesh.triangles, and then vector3 array of vertices. That's going to be mesh.vertices, and then vector2, call it UVs. That is going to be mesh.uv. And then, alright, here, just so I don't mess it up, I'm going to say UV. Oops, there we go. And a little typo there. Okay. And then we're going to do a vector3. We'll call it normals equals mesh.normals. Alright, so we've basically just cached all the data from the mesh object that we're actually going to need. So now we're going to need a couple of variables in here just to help us out. So it's going to be the triangle count. This can equal triangles.length. And then it's going to be the vertex count. That's going to be vertices.length. And then vector3, sorry, an array of those. Tan1 for tangent 1. It's going to be new vector 3 vertex count. And then we'll copy that, paste that over, but this is going to be tan2. Alright. And then we're going to use another one, but this is going to be a vector 4. And it's going to be tangents. Set that equal to new vector 4 vertex count. Now we're going to actually get in and do some work here. Create a for loop. Long a equals 0, a less than triangle count, and a plus equals. Alright. So this is going to be a little bit of a long for loop, so no pun intended. So we're going to say long I1 is equal to triangles a plus 0. We're going to do the, was it 3 times? I'm going to say plus 1, plus 2. This is going to be I2 and I3. I'm going to say vector 3 v1 equals vertices I1. Copy that 2 more times. I2, I3, and of course that's v2 and v3. And then now we're going to say vector 2, say w1 equals uv I1. And then just like before, 2 more of these. Give us a little bit more room right here. Alright, so now float x1 is it going to be, what am I doing? Alright, so float x1 is going to be equal to v2.x minus v1.x. I'm going to copy this multiple times. What do we need? 2 of those. Oops, why did I do that? It's going to be 3. Yes, okay. That was throwing me off for a minute. Alright, so now we're going to need the same thing for y and z. Yes, it's going to be exactly the same, just y and z. Alright. Now, we're going to say float s1 is equal to w2 dot x minus w1, oops, minus, there we go, w1 dot x. Alright, and then this is going to be s2 is equal to w3 dot x minus w1 dot x. And then similarly, we're going to have a T1 and T2, which is going to be w2 dot y and w3 dot y, and these obviously are going to be the y's also. Now, float div is going to equal s1 times t2 minus s2 times t1. Then float r is going to equal div. We're going to have a little ternary operator here, so div equals, or if div is equal to 0.0f. So if it is, then we're going to set r equal to 0.0f. Otherwise, we're going to set to 1.0f divided by div. Alright, so now we have vector 3 sdir is equal to new vector 3 t2 times x1 minus t1 times x2 out of that, and that all is going to be multiplied by r, and that's just going to be the x coordinate right there. And so then we're going to say for the y coordinate it's going to be t2 multiplied excuse me, t2 multiplied by y1 subtracted from t1 multiplied by y2. Oops. And that is also going to be multiplied by r. And then for our z component, we're going to say, in parentheses again, t2 multiplied by z1 minus t1 multiplied by z2 out of there, and of course multiplied by r. Now that is our sdir. We're going to copy that, and we are going to create our tdir, or t direction. Alright, so now instead of t2, it's going to be s1 multiplied by x2 minus s2 multiplied by x1, and all of that is going to be multiplied by r again. So now we're going to say s1 multiplied by y2 minus s2 multiplied by y1, and then we're going to say s1 multiplied by z2 minus s2. Sorry, I lost track. Okay, so s1 multiplied by z2 minus s2 multiplied by z1, and all that multiplied by r. So now we have our t direction and our s direction. We're almost done here. I know this is long and probably confusing. So, alright, now we're finally going to start setting our values in our tangents array. So we're going to have tan1, let's be I1 plus equals sdir, and then same thing with our I2 and our I3, and then now our tan2, I1, 2, and 3, we're going to plus equals the tdirs. Now that we've done all that, we have, all that calculation right there, it was just to fill these tangent arrays. Now we're going to do another for loop. A is less than vertex count. I'm going to say plus plus a. We're going to first off do vector 3 n equals normals a. And then, and this is just a cache over here, so vector 3 t equals tan1 A. Oops. Now we're going to say vector3 dot ortho normalize. Nifty little function, vector3 that you probably will rarely use. We're going to pass a reference to n in and a reference to t in. Then we are going to set our actual tangents arrays. X is going to equal to t dot x, and then y and z. Alright, and forgot tangents a dot w. Remember that tangents is a vector 4. Almost forgot about that myself. So vector 3 dot dot. We're gonna get the dot product here, and cross product n and t tan 2a less than 0.0f. Now, if that is true, then we will set tangents a dot w equal to negative. What am I doing? Negative 1.0f. Otherwise, we're going to set it to positive. And then all that's done, we're going to set our mesh dot tangents equal to tangents. So we've just effectively recalculated all of our tangents, so that our shadowing is going to look correct. And this is important, especially since we are going to be deforming our mesh. So every time we update it, our shadows are going to actually update properly. Alright, so let's go and minimize some of these. So right there, we've just created 3 new functions. And that, I believe, is going to get us started here. Let me go ahead and go into... Oop, did I miss something? Let's go line 147. Didn't open. 147. What did I do? What was the error? Oh. Herp derp. Here we go. Okay, so it's mesh.uv. Okay, so that should fix that. Let's see if there are any other issues. Clear. Okay. So now we're going to go ahead and, like I said, we're going to create an empty game object. Just go and 0 this out. Where's my camera at? I don't know why it's way over there. Oh yeah, we copied the scene, that's why. And let's go and put this at a -10. Actually, I'm just gonna move this back and over, give it a little rotation. Just creating a cube, so I want to give it a little bit of an angle so you guys can see it better. And we'll go up a little bit, rotate it down, and then game object. Going to be right there, and then main camera. Okay, I might need to adjust it, but we'll see. Okay, so game object, that's going to be our mesh. I'm just going to rename it. We'll say deformable mesh. Okay, let's go and drag the script onto it. Boom. Now when we start, it should create it. It has no interactivity yet. But it should create it. So let's hit play, and it looks tiny. Is it there? It is there. Did I move my camera really far away? I think I did. Let's just -10. Apparently I moved it too far. Okay, there we go. Now let's go and oh yeah, it was an ISO, here we go, perspective. There we go. Just get this camera moved in real good. Obviously you can do move it how you would. Just really depends on your scene, but just want to get a good little angle. So there, now we can see three sides of it. So now you know it's working. I could also just go into the actual scene, and we'll go and double click on this, so you can see that's just a simple cube. That's all it is. But obviously you're gonna be able to move the points. Show you the bottom. There's the bottom. Alright, and then just to show you, it does have a mesh collider, so you can see it right there. So yeah, alright. Now that we know that's working, now I guess kind of a part two. I might segue this, split it up. So yeah. Okay. So for part two of our deformable mesh tutorial, what we're going to do is in the update function. First off, all I'm going to do right now is raise and lower the point, basically on the y coordinate when you left or right click it, similar to the terrain tutorial. Just to keep this somewhat simple. So if input dot get mouse button 0, so that's going to be the left click. So if we left click, we're going to do something, and then if we right click, we want to do something. So if we left click, we want to raise the terrain. If we right click, then lower it. So of course we're going to do raycast hit equals ray camera dot main dot screen point to ray input dot mouse position, and then if physics, so basically that's just going to create a ray. It's going to go from the camera to the mouse, which is essentially makes it really easy to for mouse picking. So you know when you click on something in 3D space, you're actually clicking on it. All right, so if physics dot raycast ray out hit, we're going to call a function that we'll create in a minute, raise point, and then pass into that another function call, find nearest point, and then we're going to pass in hit dot point. So basically what I'm saying is we're going to try and raise the point, but to know what point we're actually pointing at, because you know remember the cube actually has 8 different points on it. So when we click, we're going to need to find the nearest point to where we're clicking on the object, and then we're going to raise that. So that's what we pass in. So that way raise point knows what point to raise. So then we're going to do the same thing within here, except this is going to be lower point. Yep, that's actually all we need for the update function. So I guess first we'll do the find nearest point, and then we'll segue into raise point, just because that's actually the first function that would fire off. So we'll go ahead and we'll create private. It's going to return a vector 3, because that's going to actually be the point. So find nearest point, and we're going to actually pass in a vector 3. We'll call it point. That's actually the point that we clicked on, and it's going to return the nearest point. So this is a pretty simple function, but yeah. So first off, we'll say vector 3 nearest point. So we'll just initialize it real quick. Just a blank vector 3. We'll say float last distance, and we'll just give it an arbitrarily large float value, just because I mean you're never gonna have a mesh that big basically. That way we can find out what the largest is. So for int I equals 0, I is less than points dot count, so we want to loop through every single one of our points, do I plus plus. Then we will say float distance is equal to, and then this is going to be another function that we'll segue into. So get distance, point, and points I. So we're going to go through every point in the point list, and then we're going to check the distance between where we clicked, which is point, and then each individual point in the point list. So once we get that, then we're going to say if distance is less than last distance, which is our arbitrarily large, just really big number up here. So basically, if distance is less than that, which pretty much the first one always should be, then we're going to go into here, and we're going to set last distance equal to distance, because that's our most recent distance. And then we're going to set nearest point equal to points I. And then basically every time we loop through this, if we find a point that's closer, then it's going to set the distance to last distance, and that way we can do a check on the next loop, and it's going to set nearest point to points, just in case. That way by the time we loop through all of them, whatever had the lowest distance, it's going to set that as nearest point. And then all we do is we return nearest point, which would go into the update function into the raise or lower function, raise point or lower point functions. But now we created a new, or we're about to create a new function called getDistance, and it takes two vector 3s and it returns a float. Alright, so we'll say private float, what do we call it? Oh, getDistance. Duh. GetDistance vector 3, that's going to be our starting point, and then vector 3 is going to be our end point. And then we're going to return mathf.square mathf.pow start.x minus end.x, hit equals on accident, and to the power of 2. Alright? And then we're going to add that to mathf.pow start.y minus, keep it equals, minus end.y to the power of 2 also. And then we'll do the same thing for z. Start.z minus end.z 2. Did I get all my parentheses right? Yeah, looks like it. Alright, so that's our getDistance function, which feeds into right here. So we're going to get the distance. Basically, it's the same thing, a squared plus b squared. What am I saying? So sorry, x squared plus y squared plus z squared, and then we get the square root of that. So that's essentially going to be the distance between the start and the end. Alright, so now that's everything for the find nearest point function. So now we need to do our raise and lower point functions. So I said public, private, void, it's not going to return anything, raise point, if I can spell, raise point. Remember, we're passing in the actual point that we want to raise. Excuse me. And now this is it's going to be a fairly simple one also. What we're going to do is, first off, we're going to create a variable for our index, and we're going to set it equal to -1, just because it should never, our index should never be negative, so it's just going to be real, you know, no matter how many points you have. So it's just for some quick error checking that we're going to do later. So then we'll first do a for loop, int I equals 0, I is less than points dot count I plus plus. So we're going to go through every point, say if points I equals point, so we get the correct point. We'll say index equals I, and then we'll break out of this for loop. Basically, we just want to get the actual point within here by getting that index. Now, once we break out of there, if index equals -1, as in this if statement basically never was met, because we set it to -1, so it's never been set to anything else. So if it's equal -1, we're going to say debug.log error could not match points. So we couldn't get a point match. Else, we're going to do all this. So vector3 new point, this is going to be our new point, equals points dot, not dot, excuse me, points, and then we're going to pass an index. We're going to say new point dot y plus equals 0.01 f. Now we can create a variable for this later, like basically the rate that we want to raise or lower the points. I'm just using 0.01 right now. So then we're going to set points index back equals to new point, and then we're going to call the update mesh function. Now that's what we created in the first part of this, and because we've updated the actual point, now when it goes through here and adds all these, the specific point will be different than because we just updated it. So, and that's it. We're just going to copy this, we're going to paste it for our lower point function, and we're going to minus equals 0.01. And that's it. Believe we have everything. I don't think I missed anything. Yeah. So let's go and check Uni, see if we got any errors. Oh, there we go. That'll never happen again. First time, no errors. So, alright, let's go ahead and check this out. We'll hit play. Right, we got this. If I click over here, left click, nothing happens. Right click, nothing happens. Yet if I hover over this and click, you see it's raising. Now, you probably just saw that lower one raise a little bit. That's because basically this point got far enough away from where my mouse was that this point actually became closer. So if I click right here, that's going to raise, and then eventually, oh, see, now that one was the closest one. We can also lower points. So I can lower this, lower that. So yeah, generally if it's in 3D, you're going to want to have some kind of movement or control. Obviously I don't have any kind of player, so I can't move this around. But what I want to show you is if we go into the scene view, and then here, let me just double click this. We look at this and we turn off the mesh render, look at the mesh collider, you can see that the collider is definitely updating. So yeah, there we have it, a deformable mesh at runtime. So, boom.